the module we're doing is Introduction to Descriptive Statistics. And today's topic is choosing the appropriate descriptive statistics. Okay. So we're going to go through this roadmap for the course. So we're going to look at what and why, what are descriptive statistics and why are they crucial? And then we will answer the key question, how do we choose what type of visualization to do for a particular descriptive statistics? Then we're going to dive into variable types, looking at categorical and numerical variables. And then we're going to do some matching statistics to variables, see how each statistics fit to particular variables. And then we're going to look at some example and then look at common pitfalls and best practices. And then we'll summarize and have key takeaways. Okay, so part one is what and why. Let's see what descriptive statistics is. So descriptive statistics, by way of definition, are methods used to summarize, organize, and present data in an informative way. So when you have your data sets, you want to summarize them and then organize them in ways that are understandable and interpretable by your audience, and then you can present the data in a way that is informative. And what do descriptive statistics do? So they describe what happened in your sample data. And what we mean describing this, we mean describing some basic features of your data, including measuring the central tendency of your data, which means where is the center of this data. The next thing descriptive does, it measures the variability of your data. And that means how spread out is your data. And then it also measures the frequency of your data, which means how often does something occur in your data. Now, why is choosing the right statistics important? So it is important to choose the right statistic for the right kind of data, because you need to be accurate in your description. Using the wrong statistic can give a meaningless or misleading result. For example, if we ask you to calculate the average phone model number, let's say you have iPhone 13, 14, and 15, and you say the mean will be 14. I mean, that wouldn't make sense to your audience, because, I mean, these are like categories. And iPhone 13 is a different category from iPhone 14 and iPhone 15. So it wouldn't make sense to say that you are calculating the mean or the average of those numbers. Again, another distinguishing thing which makes descriptive statistics important is it offers clarity. So the right statistic communicates the pattern in your data clearly to your audience. And it also gives credibility to your data. Proper use of statistics is a hallmark of rigorous and trustworthy research. Now we go to how do we choose? So the golden rule for your choice in what kind of descriptive statistics to apply to your data is completely dependent on the type of variable that you're trying to describe. Now, that's the single most important factor in choosing your descriptive statistics is your type of variable. Now, what is a variable in a data set? A variable is any characteristic that can be measured or observed, e.g., height, gender, satisfaction level, blood pressure. So the first question we need to ask ourselves when we're about to describe data is, what type of variable are we dealing with? basically in statistics, data is typically divided into two broad categories. So we have the categorical data and the numerical data. And these are what informs what type of descriptive statistics that we apply to those specific data. So this is just a tree showing us the types of data. Again, data types are broadly classified into two, your categorical and your numerical data. Under the categorical data, we have the ordinal and the nominal. So when we say ordinal, we mean data, a categorical data that is ordered. It's arranged in order. An example would be, for example, if you have something like marital status. Marital status, you will expect that the person is first of all single, and then married, and then separated, and then divorced, and then widowed. So we expect data to be arranged in that order. So that's an ordinal categorical variable. Whereas a nominal categorical variable is an unordered categorical variable. So for example, the states in, the countries in Africa can be a nominal kind of categorical variable because they do not follow any particular order. On the other hand, numerical data is divided broadly into two. So you have your discrete and your continuous. And your discrete variables are your whole numbers, which means they cannot have decimals in them. So an example of your discrete variable can be the number of children in a household. So you can have 2 or 3 or 4 or 5 children in a household, but you cannot have something like 2.5 or 3.5 children. Whereas the continuous variable are those that are in the definition continuous. They can have decimals in them, things like height, weight. So you can have a height of 150.5 cm or 175.6 cm. So those are continuous variables. Okay, so we go to the part 3, descriptive statistics, tables, charts, and graphs. So I will share I had done some coding in my R Studio to enable us visualize the type of variable that we can use to map certain types of descriptive statistics. So when we do descriptive statistics, I usually broadly do them in two forms. Either you're doing them as a table or you're doing them as graphs or charts. So you can describe data either using a table or graphs and charts. So either tables or figures. So we'll just look at how to make tables, how we represent variables in tables in this code. So when you're reporting a numerical data in a table, you usually report the statistic of those numerical variables because you can calculate statistics from a numerical data. And when I say statistic, I mean things like the minimum amounts of a particular variable, the maximum. You can have statistics like the mean and the standard deviation, or you can have statistics like the median and the interquartile range. So for a numerical variable, you can calculate those statistics. But for a categorical variable, you can only calculate counts and frequencies and percentages or proportions. So those are distinguishing factors between a numerical and a categorical variable. So I'm just going to show us a table that has these variables from a data set. So we have height, and we have gender, and we have eye color. So when we plot a table of height, you will see that we'll have statistics calculated like minimum, maximum, mean, and standard deviation, and then your median and interquartile range. While for gender and eye color, which are categorical variables, what we can present them as are as frequency and percentages. So I'm just going to run this. Okay, so you can see the table that has appeared. Can you see the table on the right-hand side of the screen? So this is the table. So you can see height here, which is a numerical variable, has been presented to us. You can see it in statistics, mean and standard deviation. The mean is 178, standard deviation is 33.5. The median is 183. The first quartile is 172, and the third quartile is 188. And then the minimum height is 66, and the maximum height is 234. Whereas the gender and the eye color, which are categorical variables, have been reported in counts and percentages, frequency and percentages. Okay, so that is how we report different kind of variables in a table. Again, we can also have a disaggregated table. So we can do the same table, but now disaggregate by gender. So I'm going to run the second code to show us that. Okay, so this is the same table showing us height and eye color. However, this time around, it has been disaggregated by gender. Again, you see that the height is reported in terms of statistics, minimum, maximum, mean, and standard deviation, and the median and interquartile range. Whereas the categorical variable eye color is reported in frequency and percentages. Okay, so this is how we use tables to present our descriptive statistics of our variables. Okay, now let's look at how we use figures to do the same thing. So again, it's good to know what type of variable and what graph to plot for that type of variable. So I've just prepared a small table here. If we have one categorical variable that we want to describe, we use a simple bar chart to describe it. So one categorical variable can be our gender, can be our eye color, just one categorical variable. We use a simple bar chart. If you have two categorical variables, and then you can use a special bar chart to describe it. When we say special, we mean that it could either be a stacked bar chart or a dodged bar chart. We'll look at the diagrams to describe this. And when you have one numerical variable, you can either use a histogram or a box plot or a density plot to describe one numerical variable. When you have two numerical variables, you can either use a scatter plot or scatter point to describe it, or you use a line graph. Line graphs are usually used when one of the variables is time. So when you have dates, for example, you use a line graph because a line graph shows us like a trend. Then when you have a combination of a numerical and a categorical variable, you make the plot of the numerical variable, which can either be a histogram, box plot, or density plot, and then you disaggregate by the categorical variable. Okay, we'll see examples of all of this now. Okay, so let's look at one categorical variable, which we said is a simple bar chart. So we're going to plot a graph or a chart of gender now to see how we use a simple bar chart to describe a categorical variable. So I'm going to run that bar chart that just describes the proportion of gender in this case. You have your feminine and you have your masculine. So this is a simple bar chart used to describe one categorical variable. When you have two categorical variables, we said you use a special bar chart, and that can be a stack bar chart or a dodge bar chart. So stack is from the word stack, which means one thing up on top of another. So that's what a stack bar chart means. Whereas a dodge bar chart means one thing beside another. So let's look at a stack bar chart. So here we have eye color and gender. as the two categorical variables. So we're going to see a stacked bar chart of how that. So I'm going to run this. And you can see this is a stacked bar chart. So one thing above another, it has eye color on the x-axis and frequency on the y-axis, whereas gender is stacked. You can see the male gender is this purple and the female gender is this orange. So the male and female are stacked on top of each other. So that's a stacked bar chart for two categorical variables. Another way you can describe two categorical variables is using a dodged bar chart. And this is how a dodged bar chart looks like. So you can see it's the similar graph, but instead of one on top of another, they are now standing side by side, but it's the same graph that we saw. So this is a dodged bar chart, which is used to describe two categorical variables, okay? Now, we've seen categorical variables. You can also use a pie chart to describe categorical variables, although in literature, it's not usually the norm. We hardly see pie charts used these days in literature. It's mostly bar charts that are used for categorical variables. So I will skip the pie chart part. So let's go to numerical variables. Remember we mentioned a single numerical variable can be described with either a histogram, a density plot, or a box plot. So we'll see how we use a histogram to describe the height variable. The height is a numerical variable. So let's look at how we use a histogram to describe it. So this is a histogram of height. Because a histogram consists of bins that are joined to each other. The difference between a histogram and a bar chart is that there's space that separates bar charts because they are categories. However, a histogram is describing a continuous numerical variable. Therefore, there are no spaces in between because there are no spaces between numerical variables. Okay, so that's why that's how we describe a single numerical variable with a histogram. You can see height is on the x-axis and then frequency or count on the y-axis. Then next, we're going to see how we use a density plot, again, to describe one numerical variable. So this is a density plot. A density plot is similar to a histogram. It's like a smoothened histogram. You can see this pattern and this, it has a similar pattern in terms of shape, but the density plot, it kind of smoothens the rough edges of a histogram. And that is what we have seen in this place. So again, it's the same age and density here. So this is a density plot used to describe one numerical variable. Another way you can describe one numerical variable is using a box plot. So this is how a box plot is. So this is a box plot. So it has the whiskers at both ends of this box, and this box gives us three information. The middle line tells us the median of that numerical variable. The lower edge shows us the first quartile or the 25th percentile, and then the upper edge shows us the third quartile or the 75th percentile. The end of the whiskers are the maximum and the minimum values of that variable. So this is a box plot. So again, for a single numerical variable, we use either a box plot, a density plot, or a histogram. Okay. So that's a single numerical variable. Now we move to two numerical variables. So for two numerical variables, you can use a scatter plot. So this is a plot of a graph between height and mass, which are two numerical variables. Okay, so I'm just going to run this. Now we can see a graph of two numerical variables, height and mass. Okay, height on the x-axis and mass on the y-axis. Something to note is when you're plotting two numerical variables or two variables, usually you have the independent variable on the x-axis and then the dependent variable on the y-axis. So it's very important to ask yourself which variable depends on the other. And if we look at this, the mass of someone is dependent on the person's height. So the taller you are, all things being equal, the heavier you are. So this is a scatter point or a scatter plot used to describe two numerical variables. Now, there are sometimes when we also add like a line of best fit across this, this point. So this is how a line of best fits graph is shown. So you can see it's the same graph, but we've now added a line of best fit that gives us a very fine line that shows the linear relationship between those two variables. Okay, now when another way to also describe two numerical variables is using a line graph. But in a line graph, the variable on the x-axis is usually time. So when one of the variables in the two numerical variables is time, then we will use a line graph. Because when you have time on the x-axis, you're looking at trend. And to deploy trend, you use a line graph. So we're going to look at a graph showing time and demand. Again, always use the independent variable on the x-axis and the dependent variable on the y-axis. So this BOD is a data set that shows us two variables that have time and demand for a commodity. You can see the demand for that commodity is dependent on the time, and that's why we have time on the x-axis. In fact, for most graphs that have time in it, time is usually the independent variable and should be on the x-axis. So we'll look at this line graph. So you can see a way the line graph with time on the x-axis and demand on the y-axis. So that is a way to describe two numerical variables when one of the variables is time. Okay, so two numerical variables can either be described with a scatter plot, or if one of the axes is time, then you use a line graph. Okay. Then we've seen one we've seen one categorical variable, we've seen two categorical variables, we've seen one numerical and two numerical variables. Now, how about when you have a combination of categorical and numerical variables? How do we do that? So when you have a categorical and numerical variable, what you do is that you make the plot of the numerical variable, right? And then you disaggregate by the values in the categorical variable. So can anyone remind us what plots you use to represent one numerical variable? Anyone?
A histogram.
Very good. What else?
Box plot.
Box plots again. What else? One more. Okay, the other one is a density plot. So you can use a histogram, a box plot, or a density plot to describe a numerical variable, one numerical variable. Okay, so when you have a combination of a categorical and numerical variable, you make the plot of the numerical variable, which can either be a histogram, a box plot, or a density plot. And then you categorize it by the categorical variable. So let's put that into practice and see. So in this case, we're doing a graph of height and gender. So height is the numerical variable and gender is the categorical variable. So if I plot this, so we're using a histogram in this case. So this is a histogram of the height variable, right? But now we are disaggregating by gender. So you can see this is a histogram of the height, but we're now disaggregating them by gender, where the orange is the female and the purple, or is it light green or something, is the male. So this is how you, when you have a combination of a numerical and a categorical, you make the plot of the numerical and then disaggregate by the categorical variable, okay? So either you have the disaggregation within one graph, or you can have two different graphs with each graph representing the categories of the categorical variable. So either you have it like this, or you can have it like this. And you see, so now you can see here we have two graphs, one for feminine and one for masculine. And then we have the histogram for feminine and the histogram for masculine. So either you do it this way, or you do the disaggregation within one single graph like this. So we've seen how to use a histogram to give us a plot of a combination of a numerical and a categorical variable. Now let's see how we can do it with a density plot. So again, you can see this is a density plot disaggregated by gender. So it's the same height, but now we're disaggregating it by gender. So this is the purple one is for male, and then the pink one is for female. So you, again, when you have a numerical and a categorical variable, you make the plot of the numerical variable and then you disaggregate it by the categorical variable. So either you do both of them on the same graph, or you can make it in separate graphs where one graph will be for each value in the categorical. So we can also have it represented in this way. You can see here now we have female on one graph and male on one graph. Whereas if we did it on the same graph, we can see both female and male are on the same graph, okay? Now, we've seen a density plot. Now, let's also look at a box plot. We can also use a box plot to do that. So if we run this, so this is a box plot also of height, but now disaggregated by gender. You can see the female and the male. So you can have the disaggregation in one graph like this, or you can have them in two different graphs. So you can see this is a graph for female and this is a graph for male, and then we'll have the box plots in each of them. Okay. So this is how we represent our variables in a graph or a chart, depending on what type of variable it is. So I'll just quickly go over this table again. So we said, if you have one categorical variable, you're going to draw a simple bar chart. If you have two categorical variables, you're going to draw a special bar chart, which can either be a stacked bar chart where the bars are on top of each other, or a dodged bar chart where the bars are beside each other. If you have one numerical variable, you can either represent it with a histogram or a box plot or a density plot. If you have two numerical variables, you can represent it as a scatter plot. But if one of those variables is time, then you use a line graph. If you have a numerical and a categorical variable, then you will do the graph of the numerical variable, which can either be histogram, box plot, or density plot, and then you disaggregate by the categorical values. So this is how we plot what graph to what variable. Now let's go back to our slide. Okay, so part 4 of this slide will just show us common pitfalls and best practices. So one of the things we shouldn't do is using the median for ordinal data. Using the mean for ordinal data, okay? So if you have a categorical variables, you shouldn't use the mean as a statistic to work on a categorical variable. For example, if you have, you can say on a Likert score, a Likert scale of 1 to 5, that you're looking for the mean and say the mean is 2.4, because that's a categorical variable, right? You use a median or mode instead. A second pitfall will be reporting only mean for a skewed data. So when we have a skewed data, it means we have some outliers in that data. And if you report the mean, the skewed data drags the mean away from the median. So it is good to report median when you have a skewed data rather than reporting the mean, as it might give you values that may not appear very reasonable. The third pitfall is reporting a measure of center without its corresponding measure of spread. So when you report a mean, it is important to also report the standard deviation, the variability of that mean. So when you're reporting a measure of center, let it always be accompanied by a measure of spread. Again, because they are always a pair and they should be reported together. The fourth pitfall will be using a pie chart for too many categories. And this is why pie charts are no longer encouraged in literature. Most literature you see uses bar charts instead of pie charts, right? Okay. Then best practices. So it's very, very good to always determine your variable type before you begin any analysis. You will need to know if that is a categorical variable. If it's categorical, is it nominal or is it ordinal? Or if it's a numerical variable, is it a discrete one or a continuous one? If it's a continuous one, is it a date type of variable? So you need to classify your variable first before you start your analysis. Then you need to check your distribution to see if there's any skewness or if it is symmetric. That will help you know if you are reporting a mean or a median for that variable, and will let you know if you want to use a box plot or a histogram to report that variable. Sorry. Then you also need to use robust statistics. Range. But if your data is symmetric, then it will be okay to use the mean. And next thing, you should always be transparent, report your descriptive statistics clearly so that others that are looking at it can understand your sample. And it's always good to visualize. Visuals give a very, very clear pattern to your descriptive statistics. In summary, the choice of your descriptive statistics is dictated by the variable type that you're dealing with. So when you have your categorical, either in nominal or ordinal, you use mode, frequencies, and percentage to describe it, and then you visualize them with a bar chart, either a simple bar chart or a special bar chart, depending on if you're dealing with one or two categorical variables. For a numerical variable, you usually want to report a statistic, so you can use mean and standard deviation for symmetric data, or median and interquartile range for skewed data. And to visualize it, you usually use a histogram, or a box plot, or a density plot. Always report measures of center and spread together, which means you're reporting mean with the standard deviation, or you're reporting median, you're reporting it with the interquartile range. Finally, always inspect your data visually before choosing. Thank you very much for listening.